everybody. It's Tom Kelly with Automation Alley. Here today speaking with Pat Walton. Pat is the Associate Dean for Academic Programs in the College of Engineering at Michigan State University. Welcome, Pat.
Thank you.
So tell us a little bit about your role, just so everybody gets a frame of reference of who we're talking to and what we're going to be talking about.
Fantastic. So my role is actually a new one in the College of Engineering, and it combines undergraduate studies and graduate studies. And to put it really simply, my job is to make sure every engineering student at Michigan State has a great experience and can thrive and graduate from the College of Engineering and go on to the best next step for them.
So is engineering at Michigan State, you don't want for students, do you? I mean, they're just coming. They're coming to Michigan State right now.
Engineering is in very high demand, and we'll take any student who wants to be an engineer. It's our job to make sure they get the opportunity to be successful. And so we'll happily take anyone who wants to be an engineer, and we'll try and give them the chance to succeed.
That's fantastic, because we know in Michigan, we need all the engineers we can get at this point. So that kind of leads me to my first question. So how does collaboration is all the buzzword these days in industry, in academia, you name it, everybody's talking about it. So if we talk about collaboration, how does industry and academia foster this collaboration to create innovation, to create the next thing that's going to drive Michigan's economy? How do you guys go about doing that?
So I like to think that Michigan State has the balance of excellent research productivity and excellent research programs along with fantastic students. And I think it's that combination where we have graduates who are practice ready to work from day one when they leave Michigan State. And we have research that connects to industry and allows our innovations to generate those new technologies that are going to make the economy of the 2100s and the 2200s that we don't even know exist today.
Yeah. So what are some examples of how engineering graduates that you're graduating out into the field, how are they contributing out in manufacturers and society and all the different ways that engineers impact the world?
Well, first thing, almost 60% of our graduates are employed in the state of Michigan. And so our Michigan State University engineers are the basis for a lot of the industry that exists in the state. And so we're very proud that we can support the Michigan economy in that way. And another 20% of our students are in the Midwest. And so we are helping to support all the industries, automotive, healthcare, and semiconductors, all those industries that are important to the Midwest, to Michigan. And so it's important to us to continue to build those practice ready, and I know I said that before, but really practice ready, collaborative, interdisciplinary students and graduates that can really contribute to the economy and to the industries in Michigan.
Let me pull on that string just for a minute,
Sure.
because you said it's something that is another buzzword out there called interdisciplinary. I was meeting with a high-level Boeing executive, and they said, Tom, in engineering, we gotta get our professors. We don't need to teach kids differential equations anymore. What we need to teach them is how systems engineering works, because they need to know a little bit about chemical engineering. They need to know a little bit about mechanical, a little bit about electrical, because computers are merging everything together in a big amalgamation of engineering. Talk to me about how Michigan State is addressing that real fundamental problem in industry.
Well, I think our first course in engineering is intended to build interdisciplinary teams. All of our students in the College of Engineering take our introductory course, and they work in interdisciplinary teams on things like additive manufacturing projects, on robotics projects, on community service-oriented projects. And so it is that communication across disciplines where you'll have a computer scientist working with a mechanical engineer, working with a chemical engineer on a project that's mostly electrical in nature.
Yeah.
And so they will all get the experience of applying those skills in an interdisciplinary context in a collaborative sense. So that they know that how important that communication is with their teammates, and how important those skills are in applications that maybe they hadn't thought they would be working in.
So I'm going to go a little off script here, because It's really interesting what you're talking about. How is artificial intelligence, which is sort of just the big green monster in the room that nobody knows what to do with, how is that going to enhance or hinder what you're trying to accomplish at Michigan State in the engineering program?
Yeah, I think you framed the question really well. It is both our greatest opportunity and also a significant danger. I think it's on the opportunity side, if we learn to use it and harness it in a way that can enable the things we want to do, we can maybe offload some of those tasks that perhaps don't require an engineer's time anymore. Schedule building, note-taking, those sorts of things, or interpretation of written documents or what have you that might not require that engineering design mindset. But at the same time, if we don't train our students to use it effectively and correctly, then it can get in the way of their learning the skills they need to be successful. And so it's a matter of trying to make sure all of our students are aware of how to use it correctly, when it's appropriate, and at least as importantly, when it's not.
Yeah, and so let's stay on this just for a minute, because I think it's fascinating.
Sure.
Because AI touches, most of our members at Automation Alley are small manufacturers.
Right.
And they have the same issue in that artificial intelligence in some ways is democratizing, at least where it is today, because they can go in and start typing things and get in a lot of trouble real fast, same as anybody.
Sure.
But the thing that worries me, and maybe you can allay some of my fears or maybe some of our manufacturing owners' fears, is that engineers, really at the end of the day, what you're teaching is how to think critically and solve problems. And then use the tools that you've been taught on how to do that. And I worry that AI can make people, for lack of a better word, lazy. That it has the answer, but I didn't know how it got the answer.
Sure.
Right? So I'm sure the way you're framing the problem, the way you work for your interdisciplinary teams is going to not let that happen. Maybe you could help me understand that.
Yeah, I think what we've done, and I think this is a university-wide way of thinking about it, is instructors for individual courses can define the rules for that course, right? And so in this course, use of AI tools to generate this, that, and the other might be acceptable because the focus is on something the AI can't do, right? Whereas in this other course, it may be that this is something that you need to know how to do, and you need to be able to know when the algorithm gave you something wrong.
Right. That's your critical thinking.
Know when the bot gave you something that's not correct. And so use of that tool in this context is not going to be allowed. And so I think our students and us as instructors and we as instructors are learning to navigate when those uses are appropriate and when we really need to make sure that students are doing these things on their own so that they are not caught off guard when they are in their next task and their next job and their next step.
So you answered that really well in terms of the next question I had was, what new programs is MSU working on to help address modern industry challenges? Well, that's probably top 5 in terms of industry challenges, how we think about solving these problems. What other innovation programs or things are you working on that help fill these industry challenges, these talent gaps as they exist?
Yeah, I'm really excited about our new technology engineering program that just started this semester here at MSU. It's actually a unique industry-driven discipline that we built specifically to address the needs of industry. And it is the only discipline that really has a innate kind of built from the bottom up combination of hardware and software where we're working, for instance, 2 of the concentrations in the program are mechatronics and embedded cybersecurity, where it's really trying to take those advanced tools that students are going to be working with and make sure they've had both the hands-on experience necessary to know how to work with them, as well as the theoretical underpinning on how they work so that they can work with them and design them to be more effective. And I think it's really going to be an opportunity for students who prefer that hands-on learning to apply that in a way that they've never had the chance to do before. So I'm really excited to see where that program goes.
Let's talk about that a little more because like I mentioned to you, and our audience knows this, over 3,000 of our members are small manufacturers. They're probably not needing an engineer that does design and throws it over the wall to another engineer who does the manufacturing and another engineer is doing the system for the robot, and big companies do that. But this program you're talking about that understands cyber and mechatronics, which is robotics, and additive, that's lights out manufacturing at a small scale.
Right.
Because if you understand all of that, you can actually really affect a small manufacturer. So did I get that right in terms of how I framed it, or am I missing something that you would sprinkle on top of that?
No, I think that's a great way of looking at it, in so much as we know that, especially for small businesses, everybody wears a lot of hats, right? And these are students that we think are going to be able to wear many hats simultaneously. They're going to be have the capacity to do operations if need be. They're going to have the capacity to do design if need be, and everything in between. And so I think, again, we're really excited, and we built this program specifically from the needs of our stakeholders, and so we're really excited to see where it goes.
By the way, a compliment to Michigan State. When I talk to manufacturing companies around the state, I've heard more than once, which means many times, that MSU engineering grads are unpretentious, curious, they want to solve problems. And that's kudos to your program. It's really great that that's not always the case, and that's something I would feel very proud of that remark that says I don't want pretentious kids. I want kids that want to roll up their sleeve and solve problems. And hopefully they're not kids by the time they leave, right? But we're of a certain age that everybody's a kid now.
We want adults, graduates.
That's right. Yeah. So strike that. They're all adults. We know that. Don't take offense, you young engineers out there. You reach a certain age, and I would want to be a kid again myself. So let's move to another question, which is, in what ways are engineering programs here at MSU aligning with trends like Industry 4.0, smart manufacturing, all the buzzwords you've heard, advanced robotics, to meet industry demands?
Well, I'll come back to something I mentioned earlier, in so much as our first class in the curriculum for all of our students includes additive manufacturing. It includes robotics. It includes our interdisciplinary teams. A lot of students in that course are doing app building, so they're designing apps and doing the computing side of it as well. And those are students regardless of discipline. So we could have biosystems engineering students who are doing the computational app, and we could have mechanical engineering students who are doing the robotics project, and chemies who are doing the community service oriented projects. And so it's really trying to make sure that all students recognize that their skills are both deep and important for their disciplines, but also broadly applicable across industries and across fields.
And that's awesome. And I love the interdisciplinary aspect of how it's all coming together, because that really is the world we live in and are going to inherit. So to follow on to that, it's maybe get a little deeper. So what are the key areas of opportunity for future collaboration as sort of you see them between industry and academia in the fields of AI, cybersecurity, or sustainability? These are sort of very specific drill down technologies, but they're ones that come up time and time again with our members. So we like to ask about those specific: artificial intelligence, cybersecurity, sustainability.
Yeah, I think there are a lot of different ways to collaborate. We have, I'll mention a few, like our undergraduate students have something called Design Day at the end of each semester, where they present design projects, and many of those design projects are industry sponsored. So it's the need of an organization's, usually locally or nearby in Michigan, and they say, we have this thing we can't figure out, and we need some new fresh ideas or some unbiased ideas from students. And they give these students a semester and see what they come up with, and sometimes those ideas become real plans that are implemented. We also have a similar activity for graduate students each spring, where we have a graduate research symposium where they present research that's cutting edge, and we have visitors from local industries who can talk with those students about ongoing research. And I think that's where I would build another connection, is directly to faculty members and researchers who are making those discoveries that are going to be the next technologies. And so getting industry in to connect with those folks and allowing them to take those discoveries and apply them at scale or apply them in a new field will really help generate the economy of the next generation.
Yeah, and I think Automation Alley and Michigan State may be able to play a role together, because as Automation Alley, we're trying to figure out how do we build, R&D in engineering is really limited to the largest companies that can come in and fund the research that's required. But the way we're thinking about the problem is technology is moving so fast, and the cost of discovering new things is coming down so fast in terms of your ability to say, hey, I'm doing applied research as opposed to discovery research. And so I can say, you want to see if it can do this, I can do that for you. We're trying to say, how do we pool a series of manufacturers that maybe have the same problem? I think a lot about collaborative robotics. Sure. That's a technology that can deeply impact smalls as well as large. In fact, more smalls sure. than large companies. Because if they have confidence that they would understand how the robot is going to be used and how to repurpose that technology, because that's where they get stuck. They're like, I don't understand it enough to be able to repurpose it as my order flow changes, sure, and I need to do something different. And I think that's a great role that a Michigan State could play, is because your students have that skill. By junior or senior year, they really do have the skill to be immediately effective. And in fact, we want to support that, because at the bigs, sometimes an engineer will come out and the bigs will say, okay, you sit at this desk and you do this work and you don't get to touch the real fun stuff till you're like, 35, right? Because there's so much at risk, and there's a process, and when they go into smaller manufacturers, which we need desperately, they're the big fish. And the owner is looking to them saying, hey, what should I do? How should we, can you go program that for me? And the engineer says, this is really fun, right? So I guess my question back to you was, do you think that kids that these young adults are interested in that kind of a career, where they're actually rolling their sleeves up and getting right involved right out of the gate, maybe not necessarily at the great big company, but at the medium or smaller company where they're making a big impact?
Yeah, I think one of the beauties of MSU graduates is we go everywhere. Yeah. Right? Our students end up in everything from the smallest manufacturers to the largest manufacturers to international opportunities to professional industries, law, medicine, those sorts of other disciplines. They take their skills and apply them in lots of different ways. And I, to your point earlier about being proud of our students being willing to roll their sleeves up, I think that's what typifies them in all those facets, in all those different industries. Is that MSU graduates go in and get stuff done, and they're happy to work in a team. They're happy to be part of a collaborative, and that means whether or not they are in charge of that group or part of that group, they're happy to be contributing.
Last question, and it's off script because it's just fascinating for me. Michigan State is so big, so interdisciplinary, has so many different technologies that you're experts in. I think of how agriculture would use drones to both monitor and perhaps seed fields, all the things that are going on with drones in that capacity. And then you have drones that would be completely applicable in aerospace, right? And on and on and on. This robotics and AI and additive all coming together, because the drone is probably printed additively in the academic environment, right, due to cost and just because you can do it. You know how to do it, and you buy the little motors, you assemble it yourself. So the final question is: Are you seeing more and more of that, where what's invented over here? Because you guys have MSU Innovations, right? And you're trying to kickstart these businesses just like a Stanford would do. Are you seeing that in engineering, where you're starting to see these kernels of disparate technologies that are starting to come together? Yeah, absolutely. I actually have a colleague who is a world's leading expert in solar cells and solar energy capture, who's very interested in using his transparent solar technology in farming applications, because you can set the cells up high enough that you can actually grow and ranch underneath them. So you're collecting energy on the same land that you're using for some other purpose. So you're not having to choose one or the other. And so I think there are lots of opportunities for those sorts of technologies. Smart ag is something we care a lot about because MSU is classically an important ag school for the state. And now we have all this technology we can apply to make that even stronger. So it's interesting you said with solar power. This is going to be off topic, and we're going to wrap up the interview. And I'm so happy that Pat is here. But you guys have all heard me talk a lot. When I give presentations, I do a thought experiment. I ask the audience, how do you think about manufacturing when energy is going to trend to free? When energy is no longer an input cost, it's just free. And when you see what's happening in the solar, when you mentioned your solar friend, that would be a great debate. That, you know, what you see happening around the world. And the Times, New York Times, just came out with an article about 3 days ago that said solar energy is trending to free, because once you put the capital in, you get 30 years of basically free.
Yeah.
Right. And that changes the world, because everything that we learn in engineering is a trade-off in constraints.
Right.
And all of a sudden, there's a constraint that is being unleashed on us and is going away. And it kind of boggles the mind.
Sure.
What's going to be possible when you said, well, we can have a field and we can do solar.
Yeah.
And then you got to think, where do we put that solar? Because like, I'm going to have energy everywhere, right? It's going to be pretty cool. So, Pat, this was really fascinating. Thank you for your time.
I appreciate
today.
your time. Yeah.
Yeah, and guys, stay tuned, and we'll see you next time.